So we're going to estimate the area under this curve using the left-hand method. Okay, it's a little bit better than a straight line. So let's just go ahead and do it. So the first rectangle we make uses the y-axis. And there's our first rectangle. So because it has a width of 1, all we have to do is calculate this point right here, and that will give us the area of this rectangle. So what is that point? That becomes the question. So we have an x value of 0. It looks like it's 1, 2, 3, 4, 5, 6, 7, 8.5. Let's see if that's actually true. Let's see if it's actually 8.5. So we figure that out by plugging 0 into this equation. We know the x value, so we're going to plug it in to find the y value. So 0 minus 6 is negative 6. Negative 6 squared is 36. 36 divided by 8 is 4.5. Good, so it actually is 8.5, which means this has an area of 8.5. Because the y value right here is 8.5. So moving on, our next rectangle is formed when x is 1. So we come up to where it intercepts the graph. Once again, it has a width of 1. But we need to figure out what this y value is so that we can calculate its area. When x is 1, 1/8 of 1 minus 6 squared plus 4. That's 5. 5 squared is 25. So 25 divided by 8 plus 4. 25 over 8. That looks like 3.125. So I would buy that this is 7.125. The y value, and thus the area. And we would continue doing that for each of these rectangles, calculating the y value based upon the x. And adding them all up. Until we get every single one of these rectangles. So I'm going to take a break and do all the calculations. I'll be right back with all the answers. So those are all the other y values that we calculated, and thus the corresponding areas. So when I add them all up, I get an area of 53.125, which is probably actually going to be a pretty decent estimation because all the ones on the left-hand side are overestimations and all the ones on the right-hand side are underestimations. But because the yellow one here only matches up with the green one over there, all of these ones are going to be overestimations. So 53.125 is probably an overestimation.